Hello, everyone. Welcome to another episode of our book club author chat. We're super grateful to have Adi Polak join us today to talk about your brand new book on Spark. Welcome.
Thank you so much, Sophia, for having me. Yeah, I'm excited to talk all about Spark and machine learning and building distributed systems. So I've been working with Spark and general big data and distributed systems for the last 10 years, including optimizing systems for BI analytics, machine learning, tuning performance, building SDKs, and really enabling people to do more with data. And I guess the goal of the book was a collection of a bunch of notes that I collected from conversation with customers, architects, practitioners in the field, and also trying to give another perspective into how can you dive into this kind of system yourself and kind of gain a framework to better understand how to optimize those systems and how to build on top of those systems. Because if we think about it from a larger scale, at the end of the day, a lot of us might be using cloud services and so on. And a lot of these cloud services are actually distributed systems. So someone kind of managed them for us and made it really pretty. But when we hit errors, when we hit bugs, when we hit production issues, this is when we'll need to tap into kind of the fundamentals of distributed data processing, distributed machine learning, and so on to better fix the problems and also make better decision around pros and cons of the different systems. So really at a high level, the goal, yes, we're talking heavily about Spark. There's also other technologies like MLflow, Tensorflow, PyTorch. We're talking heavily about that, but the end goal is to learn about the fundamentals of building systems that are distributed and highly available. And I see some folks, more folks are joining us. Let me share my screen. I guess what I want to say is the goal was actually to create a framework for people to understand how to scale their machine learning workflows, diving into distributed systems and solving some of the errors and bugs that we see in production. And I'm using Spark because Spark is a really good system to understand how distributed system works. There's a lot of different decisions that were made to build Spark to make it work well with the MapReduce paradigm on top of Hadoop and relatively more of a general purpose. It's not perfect, but a lot of companies are using it for different operations and it constantly evolves. Soon there should be a version of Spark 4.0. So that's really exciting to see how the internals are evolving to meet the demand from practitioners in the market. So I worked for different companies, startups, and so on. But I want to say is that so chapter one covers all the terminology and concept that would be relevant for us, for the readers that reads the book. And one of the greatest distinguished I made is we have the world of data parallelism and we have the world of model parallelism. And I'm not discussing about serving distributed model itself. I'm talking about the training part. Like how do we train the model where we have big data to train the model off top versus where we have a big model that we need to create. And it could be that we have big data and we're going to create a big model that doesn't fit into one machine memory, and that's okay. But at least we have kind of a conversation, kind of the right language to align the conversation into what it is that we're building when we're thinking about machine learning systems. And so the first chapter is really aligning on concept, how things works, what are distributed systems, what is fault tolerance, how parallelism versus concurrency works, what is the different control planes or management for that cluster that we can build. Because at the end of the day, even if we work as data scientists, we're going to meet some of these exceptions and it's not going to be pretty. And we want to be able to have the tools to fix them. So this is kind of like a very high level of the first chapter. In the second chapter, I do a specific, very short, very brief introduction to Spark and focusing on PySpark. A lot of us today work directly with Spark. Sorry, not Spark, but the PySpark, the Python version of working with Spark. And it has some pros and cons that we need to understand around the architecture, especially around data types. I know a lot of us, if you're training models and so on, training a model is only one part of the work. You do a lot of data processing, data quality, jobs that you're running in order to really reach a high quality of the data. Sometimes you're filtering, sometimes you create your own data, you generate your own data. And so you need automated tools to do that in a healthy way. And so we're diving here into PySpark, the different data formats, how to work with that, how optimization works with Apache Arrow, and so on. The open source Apache Spark itself is written in Scala and Java. So sometimes we hit the wall of the JVM. And hitting the wall of the JVM is going to impact our performance just because how threads work between the JVM in the OS, the operating system threads and processes. That's a little bit from the Java world, but essentially it's not one-to-one, and there are some improvements around threading and how to work with that and how the different locks. So that could, it's another diving into that part and really trying to simplify it, like what it is that we need, what are the areas that we're going to see, and how can I get started immediately with PySpark, and what is the potential underlying architectures. Yes, and then we reach the fun parts of managing our machine learning experiments. When we think about building machine learning systems, a lot of the things we do at the beginning is experiments, and we need to be able to manage it in one place so we can work together as a team. So we can collaborate and we can develop the model, we can take it all the way from the very beginning all the way to production. What happened in the last couple of years and why machine learning models got stuck in the development phase, that was because we didn't have those great management tools to actually bring them to the next stage and be able to collaborate within an organization. So if I'm thinking about, Google has a famous diagram showing the machine learning model itself is only part of the story. And then we have the rest of the tools that we need, which means we have a team or teams that work on it and really be able to integrate it in the beginning, going to help us do a better job. Also, if I am an individual data scientist that building my models, it will be much easier for me to go back and try to understand what I did, and also automate all the process that we're doing from model development all the way to serving it and later on archiving the model if we see fits. So it really covers all the steps. How do you do it? How a project structure looks like. So you're building the project in a way that you can later on revisit it and work in a team. And testing stages in different aspects. Yeah, and chapter 4 dives into data ingestion, pre-processing, and descriptive statistics. We can't really build a model without data. It's true that today we have pre-made models that we can take. A lot of them are not production grade yet, and we can leverage them to work with the systems that we already have. We can treat them as a base models oftentimes and build on top of them. If we think about neural networks, a lot of the models we can say, okay, I'm taking the whole network and then I'm just removing the first layer and the last layer, and I'm injecting my data into it and I'm retraining the first and the last layer to fit what I need. A very good example of that, and walking you through that book, I'm looking at two distinguished scenarios. One is working with text, so the whole NLP. You're probably more familiar with the GPT-4, GPT-3, BART, and so on. All of these models are built on text. So being able to analyze, being able to process, being able to build a neural network on text. And the second part where I'm walking you throughout the book is images. If you're working with videos, if you're working with images, if you need to do any processing on top of them, then there are different tools and different models, different base models that we can leverage, so we won't have to train models from the beginning. So people already trained wonderful models to distinguish between a dog and a cat. And maybe for our production solutions, we can take it to the next level to fit what it is that we need. But doing all the pixel classifications and so on, these are things that we probably not need to do anymore because there's good base models today that exist. And so Chapter 4 really dive into how do we ingest all the data from all the different sources? How do we run the pre-processing? And how do we make sure our data is high quality? So descriptive statistics really helps me here. And you can see that kind of an interchange log, everything works together. So it could be that some stage you're going to go back into descriptive statistics and back in, and again into feature engineering and really try to tweak and tune your model, which I think it's the most exciting part that we're seeing today. A lot of LLM models, there's already base models that great companies has open sourced for us. So we can take them and we can build on top of them. In order to build on top of them, we really need to dive into what it is that we need to build for organizations so we can monetize them as well. Because companies like to make money. If you want it or not, that's how it works. Yeah, and chapter 5 gives us a framework into how to do all of that for feature engineering, right? Do I need to handle missing data? What it is that I need to do? Do I need to extract feature from text? What can I do to better engineer my features? Categorical encoding, feature scaling, and so on. All of that while leveraging existing tools and also understanding the deep dives of how these tools work and what it is that I can do and why do I need them to start with. So that kind of gives me a really good mental map into what's the next steps that I need to take in order to reach that model grade so I can actually see some ROI from my model. Chapter 6 dives into Spark ML. And Spark ML is a general purpose. A lot of very smart people worked on Spark ML and Spark ML Lib. And there's a lot of already programmed algorithms for us to take advantage. So state-of-the-art algorithm like linear regression and so on are already built in. And if these are things that can help us create new features, create better high quality data sets, and enrich our data before we actually putting it into rebuilding a model or adding another layer for existing model, this is really, really beneficial for us. And we see more and more people in companies doing that and saying, okay, my data set is not perfect. This is why I'm getting the response that I'm getting. I need to go back and do some feature enrichment. And sometimes those feature enrichment is going to be done with machine learning algorithms that already exist to enrich my features. So chapter 6 dives into the different algorithms, looking at supervised versus unsupervised, how we can test those algorithms to evaluate them, how we can construct them in one pipeline. So it's easy for us to collaborate on these algorithms, on this workflow later on, and also add capabilities like estimators, transformers, and so on if we need those. Chapter 7. I think it's probably one of the most interesting chapters and one of the things that we see evolve really fast now in this ecosystem. This is how we take Spark and actually bridge into the deep learning framework. So when I think about from edge to AI, I need to always look at computer, right? I have some memory, I have some storage, but if I'll go one level deeper, I have my processors, right? It could be a CPU, it can be a GPU. And being able to couple some of the operations I do with my processor can help me potentially accelerate the work that I do. So a lot of folks heard about NVIDIA's and NVIDIA GPUs. And one of the beautiful things there is if CPU was built to be general purpose compute unit, GPU is built for doing heavy workloads of machine learning, matrices, and so on, more of the things that we need, especially around deep learning. So how do we connect the cluster that we have to accelerators, what exists? And this is not a solved answer yet. There's a lot of tools in the industry. And also there's a slide that I took from NVIDIA. You can see it on the right. You can see Rapids and GPU accelerated infrastructure. It doesn't necessarily mean that it's going to work well together. And we've seen things like that where the actual software that's supposed to speak with the hardware has different versions, and they didn't catch up. So interesting question to ask, and how do we connect our cluster to these type of things, and how do we leverage the actual executing engine for the my distributed system to do what it is that I wanted to do, and how to fix some of the things there. And this chapter is a more eye-opening chapter, saying a lot of things exist in the industry, and a lot of things are going to change. If you're going to implement it for your platform, for your tools, here are the things that you need to take a look at, because these are going to be kind of a barrier to execution, or it might have some performance lagging, or it might be that you won't get the best response. You'll make everything work, but you won't get the best response just because these are the pros and cons of the system, and this is physics, and this is how things work. So some things to bear in mind as you dive deeper into this. Chapter 8 already kind of part ways with Spark and dives into TensorFlow. TensorFlow, the distributed strategy. So TensorFlow, as we all know and love, is built by Google, and it's been used with data scientists for many, 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 many years now. And it also has a distributed strategy. So you can actually take some of the algorithms that we build and distribute it on top of multiple executors, and also within your processing unit. So there are different distributed approaches that you can take. And TensorFlow is a bit more flexible. It doesn't give us that head start. This is how you need to do things. This is my distributed. It actually gives us the ability to separate the things to operators and then define our graph of operations and how it is that we want to work with it. So what you see here, we have kind of like the chief that starts the program, but then we have different workers that do the job, and you can decide which worker is doing what. But we also have parameter servers, and parameter servers, or parameter serving, is one architecture that enables us to keep the weights of my model, right? When I'm creating a deep learning model, I have my different networks, and what it is that I want to optimize is the weights. The weights is where the brains sits most of the time, or at least part of it. But this is what I want to optimize. And so my parameter server is going to help me keep in one centralized place or a distributed place those weights for the model, so I can run the different optimizations. Same thing with PyTorch. PyTorch has a different approach to TensorFlow overall. Some people like that TensorFlow more, some people like PyTorch more, but it really depends on the flavor of what it is that you're used to doing, and if you're doing more research, or if you're doing more building models for companies. So it dives here into PyTorch's approach as well, how the computation graph works, how you can construct your own computation graphs, and how to do optimizations on top of it. I'm not diving into it, but you know, you've been reading the book, so you've seen that. And last is chapter 10 on deployment patterns for machine learning models. So I touched it a little bit, but essentially, when we're building a model, we want to be able to let people use it, let our customers use it. So we can deploy it inside a server, right? And we can serve it as an API, we can connect it to batch processing, or we can connect it to an already stream processing and kind of serve it from there. There are different ways to deploy it. And there's also different ways to negotiate how we want to deploy it, how we want to monitor it, and what observability looks like for my model, because I want to be able to know or have some measurement to understand if my model behaves correctly in production, or if it is a good time to archive it and build it and rebuild it. So this would be my feedback pipeline or my feedback loop that I want to be able to monitor it. And again, this is always a big question. How do I build my feedback loop for my model? And this is case by case basis. And so I really enjoyed adding a lot of different stories to show and demo a little bit of feedback loops that could be a good inspiration for you all to see how you're building your feedback loop for your models. But it also shows a lot of creativity in that process. So if at some point you are interviewing and people ask you specific questions, and I'm seeing more and more open positions for machine learning engineering, and one of the questions is, how do you build a pipeline loop? How do you build a system? How do you architect it? So this is where a lot of people require to show more creativity aspects. So there's some really fun examples that I hope you enjoyed. Yeah, I think, let me see. I had one slide that I wanted to show here. Can you still see my screen?
Yes, yes. And this is perfect. I do want to ask you questions about large language models, and this is perfect.
Yeah, please do.
Yeah, I was just wondering, like, how can we integrate this large language model? Now everyone wants to use large language model instead of using XGBoost. They want to try large language model to do similar things, or they maybe want to do more complex things with generative AI. How do you think we can integrate the generative AIs into the distributed machine learning systems to incorporate those capabilities? And just wondering what your thoughts on
Yeah.
AI in general.
Yeah. So I'm thinking a couple of directions. That really, it's a question into how do I want to integrate my LLM or my generative AI into this solution. So one thing I can say is I want to serve it and I want to wrap it, and this is what I'm selling, right? I'm selling an existing model that I wrapped with a fantastic UX, really important. And it's highly available, reliable, and people can trust to use. So there's little to no hallucination with the existing model, and I'm serving it in the REST through a REST API to my client. This is one. Another thing is I want to be able to build on top of it, or I want to be able to fine tune it, which I think is another really interesting aspect with RAG, the retrieval augmented generation, and also prompt engineering. So I'm taking an existing model and I can either use it as a base and build on top of it for my specific needs. I also need to make sure that my model is accurate, right? So if my model was trained on a data from 2022, it might be that it's not sufficient for my needs right now. And I want to make sure it has kind of a facts database attached to it. So I can go back and do and leverage existing data to enrich the response for the model or enrich my prompts currently. So we can also use Spark. There's a lot of other ways to go about it, but we can use Spark. Spark gives us the ability to write different transformations for our data, to pull, to do ingestion, and to pull data frames and to work with that. Spark also has a low level of API of mappers that we can do. So if we need to serve, if we need to use that for big data operations, this is doable. And I've seen some optimizations for Spark streaming as well. So if we need to do some micro batches, we can do that as well for the machine learning. So essentially, taking the model, right, as it is, act as a base model or not, but connecting it with data storage that is of high quality, and ingesting it and working together with it in a scalable manner, so I can give my users proper response is really critical. And something to bear in mind is with machine learning, I know we tend to generate a lot of data sets and continue, at least in the community and in the industry, we tend to build on top of each other data sets, which is great. But there's a huge ROI in companies' data because it's fresh, because it's accurate, because it's closer to being high quality. So we can leverage RAG architecture just for that.
Do you think we can serve a RAG system directly in like the way you mentioned in your book, like how to serve the Spark applications? You mentioned there are 3 deployment patterns: the batch prediction, model in service, model as a service. Do you think we can do the similar things with a generative AI application?
Yes. So maybe we can walk through some examples. Okay. Let's say I want to offer a Q&A of my product. All right. I am creating a new website, and that website is a Q&A of my product, of everything people can do with my product. And I have a great team, and every day they release new features, new capabilities, new buttons on my screen, and so on. So there's constantly fresh data getting into my system, and my Q&A constantly changes. So when I have my RAG can be served through some form of REST API on the website, and then go back and do some checking against existing data storage to understand if there's any new information for that specific prompt that the user just inserted. And Spark being also an analytics platform, we can find some similarities between what the user has been looking for and also what already exists in my data storage to enrich my prompt eventually. We can use that. We can use other tools. We can use Spark also as a data processing to dump a lot of information into my data storage to make sure it's up to date constantly. So I can build like a 5 minutes jobs that runs every 5 minutes to update what exists in my data storage. And so my model itself is being encapsulated in the REST API, which is one of the deployments. And it queries against an existing data sets that search for, and of course, I'll need to have probably a vector database in between to validate the different similarities of against the data that I have. I hope that answered the question.
Sorry, I was muted. Yeah, that's really helpful. Thank you. And I'm just wondering, like in the traditional machine learning model, you also have the feedback loop, right? When you monitor the data, see the model, model drift, data drift, and then you decide sometime to retrain the model. Is that the same thing? Do you think that similar things will happen with AI in production, the generative AI world? Or do you see there's some difference there?
Yeah, that's a great question. So one of the things I've seen in the industry is human in the loop feedback. So we see it pretty extensively with everything generative AI. There's always like this answer, like give me a thumbs up or give me a thumbs down. That then it's answer your questions. Is that what we're looking for? So one of the things we try to solve with feedback loop at the very core is the actual model behavior results. the actual behavior expected, the actual behavior of a user, or what it is that we wanted to answer as give as an answer, versus what we got from the model. And if it's a finite number, for example, the right cost is going to be $50 predicted, but at the end of the day, it costs $70. These are facts. These are numbers. Here I can say, you know, there is discrepancy between what the model predicted versus what we actually saw in real life. With generative AI, because it's generative, we need to have human in the loop to give us feedback. We need to know from a real person that has reasoning abilities to know if that response actually makes sense. Because what's happening in generative AI, it learns from lots of texts, and it runs some similarity algorithm to different extent, and there's a different tuning aspect to those similarities. But the thing is, it doesn't necessarily know how to reason about why these things happened, or why the response is the way it is. It generates according to what it saw before and the probability of what will be the next word, the next sentence, and so on. And here we probably want to, this is why I'm saying we need to have a person, a human in the loop that can reason about the answer, about the response, and can tell us if it's good enough or not. So we can definitely add that as an architecture, and definitely in the feedback loop, develop a really good UX and UI where our customers are engaged to give us response, right? They get enough value so that they're engaged. The UI is friendly. And also for us to take that feedback and try to distill it into or normalize it so we can make decisions later on.
Yep, that makes a lot of sense. I want to give a chance for our book club members to ask questions. We have a few joining here. If you have any questions, feel free to ask directly or type in the chat.
Hi. Hi, Adi. Hi, Sophia. It's nice
Hello.
to see you. I just want to follow up on the last question that you asked Sophia and Adi's answer. So we do have humans in the loop, but each human brings her own bias, and it also depends on the questions. And it's just, to me, this just grows exponentially, and to try to make sense of it, to normalize it, it's a whole other huge problem. Or maybe I'm exaggerating, I don't know. It's just, it feels like we can start small, right, and just be a thumbs up or thumbs down, but what does that exactly tell us? And even if we just think from a regular ML algorithm data perspective, right, sometimes we make decisions that, you know, just seems like the right decision to make, but I think I lost my train of thought here. It just it's hard to make a decision of where to start, how to iterate from there, and where to stop, right? I see like well, LLMs are non-deterministic, right, in the answer. So to make us, we put humans in the loop, and to try to make a sense of it, are we trying to make it deterministic, or do you get where I'm going with my rambly question? Sorry.
Yeah, no, I
Thank
think
you.
Yeah, it's a great question. You know, the feedback loop for LLMs are really, really a tough one. So some companies are installing a labeling team, right? We have this team that is expert or domain experts on, you know, some Q&A that we're building. They know exactly what should be in the text that we retrieve. and they can give us a grade of how good it was. Well, that's great. It doesn't always scale. So some of the things I've seen is some companies will start with that, having a labeling team, putting in some expert they know is as high grade, and then bridge into k-means algorithms to see if they can classify their responses for the model if they're close to what they already have labeled. So it's a semi-supervised problem. We have some information, some data with high quality labels, and then we have what the model retrieved. It's not, again, each use case would have its own challenges and frictions, and how do we even know, the answer that the model gave is very close to what the expert would have said, and so on. But that proximity can give us numbers to start the process of evaluating our models in production. I know it's not the full answer, but maybe it helps kind of with a more creative approach to what it is that we can do today.
Yeah, so we are still in the dark, right? But we're trying to shine some light and do whatever we can. And yeah, I remember when Databricks created their data model for their Dolly, right? And I think they made 15,000 training sites, and they just wrote a blog afterwards that how difficult that was. And but they did it very scientifically, and it was their own employees, and it was very strategic, right? How it was done. But even at that level and in that very consistent framework, right? It was so difficult. So here, yeah, even the simplest example of reviews, right, for products. And there are data sets, a lot of them there, and I'm sure you know a lot more about this than I do. So it's just, okay, we are starting small, it's dark ages, but we're getting there, and learning, and people are more open, and there's a lot out there, and we all learn from each other, and we're moving the needle, right? That's what you're saying. That, okay.
Yeah, and the smaller the problem, the better it would be to build a high performance model. And when I say high performance model, when we talk about real systems, production systems, monetized systems, commercial systems, 70% is usually good, right? It's not research. So we're not looking for the 90, 95%, like 70% is great. So something to distinguish between, building those systems for a commercial solution versus building them for research.
Great, thank you.
Going back to the book, I was wondering, what are the challenges you have seen with distributed machine learning systems?
Yeah. So there's a lot of evolution happening very fast in this space. It's hard to get high quality data, and so a lot of researchers has created their own data sets, and we see it, and it's successful. So that's amazing. We see some of the models are actually very, very successful, and it was all curated data set that someone actually defined the rules and said, I'm going to build a data set based on these rules. So this is also one of the challenges. Another challenge is resources, lack of GPUs. We've seen it pretty vividly. It was hard to get GPUs for some time. I think now maybe it's a little bit better, but again, it's hard to get hands-on, and it's also expensive. So when approaching a project like that, it's always good to understand what would be the potential ROI of that project? What is the little thing that I can build now to see that there's a good potential within that project? So really taking the big project and breaking it down into stepping stones, taking the first step, something that is relatively low cost, understanding that there is continuing to iterate on that until we hit kind of a wall and say, okay, this is it, we can't really get more ROI. Because at the end of the day, if my compute and if serving the model is going to cost more than the actual produce for the company, this is also going to be another big question of, should we keep it alive? Is there a potential in it, in that space? Another area is a lot of algorithms. Sometimes if you think about machine learning algorithms starting from the very basics, it will be hard to distribute, and there will be pros and cons to distribute some of the algorithms. There's a price to pay, and depending on how many machines, what it is you want to do, at the end, it's a stochastic system, right? A stochastic system that builds stochastic system. So there is that challenge, and as well when we think about accuracy, and also the challenge of knowledge. If we think about Google DeepMinds or Meta with all their great models and so on, OpenAI, these companies build distributed machine learning system. This is not the traditional day-to-day thing that we see as sometimes that students are engaging with in universities and courses. And so these are often being optimized for a very, very specific use case. So understanding of how distributed systems works can really help people to build a system that is relevant for their specific use case. This is why, some of the chapters dives into communication. How it is that you do networking here? What's the price of the different networking? How do we make sure our parameter server is actually accurate? What's the level of consistency? Things that comes from computer science heavy concepts as well. Yeah.
Thank you. That makes a lot of sense. So some people are trying to decide between a batch system versus a real-time system. What's your thoughts on that? From your observation, do people really need real-time systems, but it's just so much more complex and need a lot more attention?
Yeah. So there's a difference between real-time, near real-time, and stream processing at a very high level, and it depends on who is the person interacting with that system. So, or what is the figure that interacts with that system. If I have an automated system that interact with my system, then yes, I need more real-time, and of course, if there's a demand for it, and so on. But if I have a person interacting with my system, could be that I have a good couple of milliseconds or seconds to do some processing and get a response. And so near real-time systems could work for my case. Now, if we're taking it back to machine learning, one of the challenges is querying against an existing model could take a long time. If you've been trying, all the models, it sometimes takes the time for the model to return a response. And that's, again, depend how I'm serving it, if I have a GPU available or not, how did I tweak it and tuned it, how big is my model, which edge case am I facing now within my model, and so on. So that speaks more to the user experience that uses my productionized model to work with. And the challenges there are pretty interesting. It's more innovative space. Sometimes companies, what they will do, and this is kind of a workaround for that, is they give users a fixed amount of questions that they can ask. So they're able to generate that information in advance and cache it to memory so it feels real time. And that depends on, again, my business logic. And if I'm able to do something like that, like for example, if I'm giving a user or customer dashboard, I can have a limitation into what's indexes, what type of questions, or kind of high-level structure, or kind of high-level keys that the user can use to query against my LLM. And I know my LLM is optimized for these specific keys because under the hood I'm adding some more information into it with prompt engineering and so on. And so I know this query is going to work really, really well in real time. But you're right, this is still an open question on, how we're going to do it, how we're going to fine tune it. To be honest, I'm not sure if we'll have a holistic solution for that, because compute is compute. An edge case is going to be an edge case. It always takes longer to compute. But I think finding a specific solutions for specific problems is definitely going to work really, really well in those cases. And also understanding if we actually need to query against the model in real time, or can we, run that in a batch processing and then cache it to my server and just serve the answers, from any in-memory database that I can have instead of actually computing it from scratch.
Right. I really like your Google example, that things could be not real time, but it feels like real time. That's a good trick.
Yeah, a lot of the search engine queries that we're running, right? A lot of the data is already indexed, optimized.
Right.
Yeah, we're querying against an optimized database that's constantly being updated.
I know you have a lot of slides. Is there anything else you would like to show us?
Let's see if I had anything interesting in here. Yeah, maybe just this one. Just this one at a very high level, saying that distinguishing between development, staging, and production systems is really critical. And I believe a lot of the work that we're going to do is going to be actually here, because we're building great models. We want to bring them to production. We want them to do great things. And a lot of, in my opinion, a lot of the innovations is going to be around like all the great questions, and all the conversation topics we brought here today, like feedback loop, optimizations of serving. Do we actually need to cache it? What is going to happen with my real-time application? Yeah, so this is kind of like one of the slides that I really like.
Awesome, thanks. I guess I have some final questions since we only have a few minutes. What do you think is the future of Spark or the data ecosystems around Spark?
Yeah, that's a really good question. So Spark 4.0 is probably coming up next year, June, July. And there's a lot of optimizations around machine learning that I think would be really interesting to see. And Spark is a system that exists in so many analytics infrastructure, and it served a lot of analytics folks so well. And I'm really looking for the day that more and more machine learning practitioners are going to leverage that, not necessarily to build their models, but to build a system around that where they can run the model against the data, pre-train pre-process the data for the model, do all the high quality filtering, pre-processing, descriptive statistics, and so on, so we can actually leverage big data tools to build better models. So I think it would be really, really interesting to see how things developed, and they're all already kind of a competition. It's not exactly a competition, but kind of other frameworks, other open source frameworks that enable specifically distributed machine learning systems. So it's great to see more tools coming up, because that means there is a need. And people see a good reason to build those and to contribute to those in the open source space. Yeah, I think it's getting another run at that space.
Awesome, I love it. One complaint I have about Spark is the MLlib, the syntax. Why doesn't look like scikit-learn? If it looks like scikit-learn, like it will make everyone's life so much better if they could just unify the API to be consistent.
Yeah, so there was a project with PySpark in Pandas named Koalas, and now I believe it's Pandas on Spark. That if you're coming from a Panda world and you used to do a lot of your data processing with Pandas, so now it will be very easy for you to move into big data space and run kind of Pandas on top of Spark. So I agree. And yeah, scikit-learn, this is an opportunity, and this is why Spark is open source, so a lot of people can open requests and also contribute. It's one part of the community.
Nice, I love it. I'm so glad someone made the Pandas version for Spark. Yeah.
Me too.
I think, do you have any final words for us, for people who want to learn more about Spark? What are the resources, other places you would recommend us to read?
Yeah, so there's a lot of great books out there. There's a lot of great courses out there. I'm now building a new course for Rally with a new version of Spark coming up. So probably in the next couple of months, everyone would be able to consume the course on the Rally platform. And of course, if you want to use, there's the managed Spark on the Databricks environment, which is available on AWS Cloud and also on Azure Cloud. Spark there is already optimized for you, so you don't need to do a lot of the optimization part. You can just, spin a cluster and start working with it. And there's also another Databricks solution that you don't need to spin a cluster, essentially serverless for you, so you can start writing your code and works against your data. There's of course other solutions on the different clouds that's available for you, but I'm a big believer in get some hands-on, run some tutorials, run some scripts. I don't know if you notice it, but I developed 10 notebooks in the GitHub repo for the book. So everyone who wants to, immediately get hands-on and start rolling with it can. You can run it locally in your Docker. Of course, it's not going to be distributed because it is on your laptop. At least you can start understanding how the syntax and the API works, or you can import it into a Databricks cluster and run it there. It will work for you as well. I tested it out. Yeah, and there is so there's Learning Spark, which is a great book, and I know there's also version 2 of High Performance Spark is coming soon, next year, which will have generative AI in it. I know it because I'm helping the other to write that chapter, so should be interesting, coming up soon. And yeah, I believe the more hands-on we'll get, the more we'll be able to understand the fundamentals as well.
Thank you so much. Yeah, I do like you have the GitHub repo for your book. It's really helpful. Okay, I guess that's it for today's author discussion. Thank you so much, Adi.
Thank you.
Really, really appreciating you coming talking to us. We're looking forward to attending your course and your new book chapter.
Thank you so much. I was really excited to be here, and I'm happy to see, more people wants to grow in that field and grow their skills. So I'm very excited for you all.
Thank you, thank you.
Thank you.
And thank you everyone for attending. See you guys later. Bye.
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 Good night.